In this unit, we're going to begin the study of trigonometry, which is just the study of triangle measures. And as you will see that in trigonometry, we're going to begin to learn how to connect the side length in a right triangle with the angle measures of the acute angles in a right triangle. So before we start, we need to understand some trigonometry ratios. Remember, ratios are simply fractions, so there's nothing more fancy or less fancy about it. It's just a fraction. So the first thing we have to learn is the concept of sine right here. Whoops. Sine, and then we're going to learn cosine and tangent. So sine is defined as the ratio of the opposite leg of the angle to the hypotenuse. Okay, so sine, in our example on the left here, I have triangle ABC. And so if I'm looking at angle A here, the opposite of angle A is my side length A. And my hypotenuse, which is opposite of the 90-degree angle, is C, right? So I should have used my gold color right there. So it's opposite over hypotenuse. So if I look at angle B here, my opposite is small letter B, and my hypotenuse is still C, right? Cosine is the ratio of the leg adjacent to the angle over the hypotenuse. So again, if I look at A, the leg adjacent to it, there are two sides, B and C. B is a leg, C is a hypotenuse. So the leg adjacent to it is B. Then hypotenuse is C. If I have to find cosine B, the adjacent leg is A and over hypotenuse. And finally, tangent is simply the ratio of the leg of the opposite leg. So if I'm looking at tangent A, opposite is A, the adjacent leg is B. And tangent B, the opposite side is B, the adjacent leg is A. So tangent is all about the legs, okay? Tangent is all about the legs. Sine and cosine, you have to bring in the denominator, which is the hypotenuse. So there's actually a quick way to remember this. It's called Sohcahtoa. So it's sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite leg over adjacent leg. So if we write this out, it's sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's what we call Sohcahtoa, and this is something you really need to memorize, and you're going to hear your teachers talk about it again and again and again, not only in geometry but eventually in pre-calc. Sohcahtoa, that's the definition of these three ratios. Again, at this point, all you need to understand is these three ratios is a fraction, and that's based on the side length of the triangles in a right triangle. So let's look at some practice problems here. I have a right triangle here, and I have 12, 5, 12, 13. This is one of the Pythagorean triples. So if I'm looking at sine A, if I'm looking at sine A, so A is here, sine is so, right? So I should write it out. Sohcahtoa. So is opposite is 5, hypotenuse is 13. Cosine A is chi is adjacent leg is 12, hypotenuse is 13. Tangent is opposite leg, toa, is adjacent leg. So that's it. That's my definition. Now if I look at sine C, here, sine C, opposite is 12, hypotenuse is 13. Cosine C, adjacent leg is 5, hypotenuse is 13. Tangent is opposite leg over adjacent leg. Okay, so finish 2 and 3. And 2 and 3, they only give you 2 legs, or 1 leg, 1 hypotenuse, so you have to use Pythagorean theorem first to find the third leg, and then calculate all the ratios. And one of the things that's really important is here, make sure your calculator is in degree mode. Some of them may also be set in radian mode, so you want to get rid of that and make sure that you have the degree mode. Okay, so right here we're going to solve for x in example number 1. So in this case, this is given, the angle is given. So if I have sine 28, because I have the opposite leg, I want to know the opposite leg. I'm given the hypotenuse already, so I can simply set up this trigonometry ratio, right? So I have, if I multiply 19 on both sides, I should have x equals sine 28. Remember, I just want to stress again that this looks intimidating at this stage because it's the first time you're seeing it. But remember, I said earlier that sine, cosine, tangent, trigonometry ratios are simply a ratio. It's a fraction. So if you plug in your calculator, you will see what sine 28 is. So you have to use a scientific calculator or a TI-8384. So if you plug in sine 28 and then use that decimal point multiplied by 19, you should have x equals 8.9, I believe. That's your final answer. Okay, let's look at number 3. So this time I want to know the adjacent leg, and I know the hypotenuse. So it's better if I use cosine. Cosine 21 equals adjacent leg over 26. So 26 times cosine 21 should equal x. And plug in your calculator, you should have 24.3. And that looks about right. It's less than the hypotenuse, but it's very close, right? So the rest of the practices are more or less like that. And let's look at number 9. I'll do number 9 with you. Jake leaned a 12-foot ladder against his house. If the angle formed, so again, if I have a house here, and then he leaned it against the house, so the house would be here. This is more like a castle, isn't it? So he said this is 12 foot. And if the angle formed by the ladder to the ground is 68 degrees, meaning if this is 68, that's the ladder and that's the ground at the bottom, so that's 68 degrees. How far from the base of the house, the base of the house is right here, did he place the ladder? So I'm looking to know this green line here. And obviously I have a right triangle here, right? Because I'm looking to find my adjacent leg, so it's better to use my cosine. So if it's cosine 68 degrees equals adjacent leg, which is x, over hypotenuse, which is 12. So x should be 12 times cosine 68 and equals 4.5. So the answer is that it's about 4.5 feet from the base of the house that Jake placed the ladder. Okay, so for word problems, it really is helpful to slow it down, translate it into a graph, and label all of your data points, and then see what you can do about the right triangle by using trigonometry in this unit. Okay, finish the rest of the packet, and I'll see you in class. Bye, guys.